Good morning, students. During the previous class, we discussed about the earlier attempts of the scientists for the classification of elements. We mentioned the scientists, namely Lavoisier, then Dobryner, Lothar, Newlands, and Avogadro, and Mendeleev. These are the 5 scientists who spent their time and life for the classifying the known elements at their time. First is Lavoisier, who classified the elements, the metals and non-metals. In his time, only 30 elements were known to the world. Then came the Dobryner. His classification is known as triads. Triads, triads. 3 elements were grouped together. Those elements which have similar properties are grouped together among 3 elements. Hence, his classification is known as triads. Then came the Lothar. His name is not mentioned in the textbook yet. He found the relation between the size of the atom or the volume of the atom and the atomic mass. He drew a graph, a curve between atomic mass and atomic volume. It is known as atomic mass atomic volume curve. There is he found the relation between the size of the atom and the mass of the atom. Then there gives the scientist, namely Newlands. He put forward the law of octaves. Newlands' classification is known as law of octaves. That it says that when the elements are arranged in the increasing order of their atomic masses, the property of the 8th element is same as that of the first element. So hence his law is known as octet, OCT, octet law. Octet means 8. Yet he can't make full success in his attempt. This Newlands law of octaves obedient only applicable only to the elements up to the atomic number 20th. Then from the 21st onwards, he cannot continue his attempt, or the rule does not follow the element 21 onwards. So the law of octaves is limited to the classification for a limited number of elements. Then there came the famous scientist, namely Dmitri Ivanovich Mendeleev. I already said to you that Mendeleev is known as the father of the periodic table. He was a scientist who succeeded in classifying the elements. He put forward the first periodic law. Mendeleev's periodic law is known as Mendeleev's periodic law. Then came another periodic law that is known as modern periodic law. In Mendeleev's time, about 63 elements were known to the scientific world. He classified the known 63 elements according to the ascending order of their atomic mass. The basis of Mendeleev's classification is atomic mass. The basis of Mendeleev's classification is known as atomic. The basic classification is atomic mass. He drew the first periodic table. It is also known as Mendeleev's periodic table. In Mendeleev's periodic table, it is given into your textbook. In Mendeleev's periodic table, there are horizontal and vertical columns. There are 8 vertical columns. This is known as groups, and 6 horizontal columns, and these columns are known as periods. There are several merits and demerits. First merit is he is the first person, he is the first scientist who succeeded in classifying the elements. In Mendeleev's periodic table, there are some gaps, and he said to the scientific world that these gaps were to be filled by the elements later to be discovered. He also predicted the properties of those elements which was not yet discovered. There. Then one more merit is he could correct the atomic masses of several elements. He could correct the atomic masses of several elements because he arranged the elements according to the ascending order of their atomic mass. When they are arranged in the ascending order of their atomic masses, he found that certain elements fall in their positions, correct positions. Yet he recalculate and correct the atomic mass of those elements. He also placed positions for the isotopes also. These are the two main merits. He could predict the properties of those elements which has been not yet discovered. He placed gaps for those elements. Second is, he could correct the atomic masses of certain elements. He also find positions for the isotopes of elements. The demerits are that he takes atomic mass as the main factor of the element. Mendeleev classified elements on the basis of their atomic mass. He thought that atomic mass is the most important part. That is not right. Later inventions discovered prove that not atomic mass but atomic number is the most important factor in the case of an element. Then the second effect is certain elements does not follow the ascending order of their atomic mass. Certain elements, the atomic ascending order of the elements could not find a correct order in the case of certain elements. These are the two demerits. Yet he was the first scientist who succeeded in classifying the periodic table, and he put forward the periodic law. Mendeleev's periodic law is known as Mendeleev's periodic law is stated that the physical and chemical properties of the elements are the periodic function of their atomic mass. The physical and chemical properties of the elements are the periodic functions of their atomic mass. Then came the most important periodic table, that is known as long form periodic table. The long form periodic table is based on modern periodic law. Modern periodic law stated that the physical and chemical properties of the elements are the periodic functions of their atomic number. The modern periodic table depends upon the atomic number. In 1913, the scientist named Henry Moseley in 1913, the scientist named Henry Moseley, who that atomic number, not atomic mass, was the main factor of an element. So then Moseley rewrite the Mendeleev's periodic law. The physical and chemical properties of the elements are the periodic functions of their atomic number. Then he classified the elements on the ascending order of their atomic number. He says that in the case of element, the atomic number is the fingerprint in the case of an element. So, the modern periodic table, it is given in your textbook, is on the basis of the atomic number. We can have a look at the modern periodic table. This is the modern periodic table. It is also known as the long form periodic table. It is based on the basis of this modern periodic table is atomic number. So we can have, whenever you are studying chemistry, we have a clear idea about the modern periodic table. If you look at the periodic table, there are several horizontal and vertical columns. These vertical columns are known as groups. These vertical columns are known as groups. In some cases, students make a mistake between horizontal columns and vertical columns. Horizontal column, this is here you can see the number. This is a first group, first vertical column. First vertical column is this. Its number is 1. This is the second vertical column. When you say the vertical column, you will have a look at from the top to the bottom. Not a single element. This is the third vertical column, fourth vertical column, fifth vertical column, sixth, seventh, eighth, 9th, 10th, 11th, 12th, 13th, 14th, 15th, 16th, 17th and 18th. In the modern periodic table, you can see 18 vertical columns. 18 vertical. These 18 vertical columns are known as groups. So, in the modern periodic table, there are 18 groups. 18 groups. The first class, I told you that our view is or our aim is, or the scientists aim for the classification element is the study about the elements becomes simple and easy. So, similar elements, those elements which have similar properties fall in the same group. Group means, I already said that in political parties there are several groups. One group means those persons which have the same view, same idea are called in one group. Those persons which have a different idea or different view come under another group. When there is a third group, they have an idea other than the first two. So, in the case of elements also, the first vertical column is known as the first group. Second vertical column is known as second group. Third group, fourth group. So, the last came the 18th group. Then we can see several horizontal columns. The horizontal columns, here is number written as class 1. Horizontal column means here I will always read from left to right. The horizontal column from here to this. In the first horizontal column there are only 2 elements. The second horizontal column, this. When we say second horizontal column, you will have a look at all the elements in the second column. Third vertical column means this. 1, 2, 3, 4. This. Fourth vertical column means these all elements. Fifth horizontal column, sixth horizontal column, seventh horizontal column. Then when you see there is a separate section 6 and 7. This is sixth horizontal column. Here we see LA. His atomic number is 57. His continuation is 58 here. Similarly, seventh horizontal column, you can see AC actinium, its atomic number is 89. This continuation is 99 from onwards. So it is these two columns, these two horizontal columns are the continuation of these 6th and 7th horizontal columns. These horizontal columns are known as periods. So in the modern periodic table, there are 18 vertical columns. That means 18 groups. Similarly, there are 7 horizontal columns. That means there are 7 periods. In short, in modern periodic table, elements are arranged in 18 groups and 7 periods. In modern periodic table, the basis of modern periodic table is atomic number, and in modern periodic table, elements are arranged in 18 groups and 7 periods. The first two things, you must remember the modern periodic table is these two things. What are they? The basis of modern periodic table is atomic number. That means in modern periodic table, elements are arranged in the ascending order of their atomic number. Second thing you must remember is what? In the modern periodic table, there are 18 groups and 7 periods. 18 groups. Then the third thing you must remember, what are groups? The vertical columns are known as groups and the horizontal columns are known as periods. Then again you come back to look at the other things. How many elements in each group and each period? How many elements in each period, each group and each period? This is the first group. This is the first group. Earlier I told you that when you think of when you have a first group, you must not point out only one element. Whenever you seeing the period table, the first group means all the elements here from top to bottom. That is hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. First group means not the one element. First group means all these 7 elements. Similarly, second group means second group you can't point out. If you point out 2, it's okay. Then what are the elements in second group? You must point out all the elements from beryllium to radon. Then the most important thing about the periodic table is the common elements, the representative elements. You can see, you have a look at that. This is first A, second A, third B, fourth B. These groups are again divided into A and B. That means the most A groups are the common elements and they are known as representative elements. That means first A, second A, third A, fourth A, fifth A, sixth A, seventh A, and 18th because these are the representative elements. Then these B group are transition elements. Third B, fourth B, and first B, these orders. Then what are the elements in second A group? How many elements? You must have a clear idea, a close look at each element. In second A group, that means second group, what are the elements? How many elements are there? 1, 2, 3, 4, 5, 6. In second group, there are totally 6 groups. In third group, first you have to look at the A group. Third group, how many elements? 1, 2, 3, 4, 5, 6 elements. 14th group or 4th group. 14th group, how many elements? Here also 6 elements. 15th group also 6 elements. 16th also 6 elements. 17th group also 6 elements. The 18th group again came 7 elements. So you must remember the number of elements. You don't bother about the name and symbols. Several times when you repeat the names, you might automatically, when you repeat the names, then when you see the symbol, the name must automatically came to your mind. For example, hydrogen, whenever you see the symbol H, you can know that, you will know that without learning by heart, hydrogen H represents hydrogen. Similarly, Li represents lithium, Na sodium. So then the number of elements in each group, especially in A groups. You must remember the number of elements in each group. Each group is also known as a family. What do you mean family? In a family there are several members. They have almost similar properties. Almost similar properties. But there is a gradual change. There is a gradual increase or decrease in their properties. Yet they must have a common so many properties, so many qualities in common. So they are all under one group. The first group. So a special name is given to each group. The first group is known as the alkali group. The first group is known as alkali group, alkali family. The second group is known as alkaline earth family. Similarly, the third we must remember more about the A group. Third A, this is known as the boron family. The head of the boron family is known as boron. B, boron. B, the symbol B represents boron. Then the fourth group or body group, there is C. This is carbon family, because the head of the fourth group is known as carbon. So it is known as carbon family. 15th group is known as nitrogen family. When you refer nitrogen family, you not point out nitrogen. Nitrogen family means all the members of the nitrogen, that is nitrogen, phosphorus, arsenic, antimony, and bismuth. This oxygen family, this the 17th group is known as halogen family. There are several letters UUT, UUQ. This is the naming is nowadays the naming or name of the if an element is discovered, the scientist gave its name. If an element is came to study or approved by the scientists, there is a international organization that is known as IUPAC, International Union for Pure and Applied Chemistry. If an element is discovered anywhere in world, then if it is came under the purpose of study, or if it is approved by the government, not the government, not the world, this world organization must approve first. That is the world organization for the chemistry was IUPAC, International Union for Pure and Applied Chemistry. International Union for Pure and Applied Chemistry. This organization was given name and approval. If a scientist discovered an element, they must produce this element before this organization. If they approve this organization or this IUPAC or approve the element, then only we can study it, and they only prove the existence of. They are the authorized agency for approval for the approval of any element or any compound which is newly discovered. That is the name of this organization is, you must remember, IUPAC, International Union for Pure and Applied Chemistry. Then the 18th group, there are when you refer 18th group, helium, neon, argon, krypton, xenon, radon, and neutron. This elements also are known as, this family is known as inert gases. Inert gases. This 70th group is known as halogen family. So the elements, there are 18 groups. 18 groups. The A groups are known as representative elements, and in the A groups, each group is identified by a special name, a special type of family name for each group. These representative elements of this 8th group, they are identified by a special name. A special family name was also given to the each A groups. That is alkali group, alkali family, alkali earth family, boron family, carbon family, nitrogen family, oxygen family, chlorine family, and inert gas. Then you must also remember the number of periods. Then we came into the periods. What are periods? The horizontal columns, the periodic table is known as periods. The horizontal columns. The horizontal column. Whenever when you are studying, there is students always make a mistake between the horizontal columns and the vertical columns. When you are studying the vertical columns, the first vertical column, you must remember only these. Don't forget other columns. Similarly, when you are studying about the horizontal column, the first vertical horizontal column, there are only two elements, that is hydrogen and helium. Two elements. How many elements are the second period? Period, I already said that period means horizontal columns in a period. Second horizontal column, that is second period. How many elements are the second period? 1, 2, 3, 4, 5, 6, 7, 8. Then came the third period. How many elements are the third period? 1, 2, similarly 8 elements. Then came the fourth period. Fourth period, how many elements are there? 1, 2, 3, 4, 5, 6, 7. How many? 18 elements. The fifth period also, how many elements? 18 elements. The sixth period, how many elements? In the sixth period, I said to you that these, in addition to these 18 elements, how many elements are this also? Here also, there are 14 elements. So how many elements here? In sixth period, there are 32 elements. The seventh period is also incomplete. Incomplete means in addition to these 18, this again contain these more elements yet to be discovered. These elements are added in addition to this. So now there are also 32 elements. So first you have. So I think you must have an outlook on the period table. Then you must come to the first and most important thing. What is it? Atomic number. I said to you that the elements are arranged in the increasing order of their atomic number. For example, in the hydrogen, there is the brass, there is a small electron. This is 1, atomic number 1. Helium, atomic number 2. The elements are arranged in the increasing order of their atomic number. Lithium 3, atomic number 3. Beryllium 4. Boron 5. Carbon 6. Nitrogen 7. Oxygen 8. Fluorine 9. Neon 10. When the elements are arranged from left to right, the increasing order of their atomic number from left to right. The left to right, the atomic number increases from left to right. This is the base. Then we can see the one for the position. The first class I said that what? It's a multi-storied building. There are how many rooms? These are several rooms, and each room is allotted for a special element. How this element is allotted in a special room? Each column is known as a room. This is a multi-storied building, and so there are how many rows and columns? Also, many horizontal columns and vertical columns, and each column then goes, there are so many rooms. These are also a separate room for each element. Then the scientists allowed a separate room for each element. How they allowed the positions, they fix the rooms for each element. How the hydrogen is placed in this row. Hydrogen is allotted for this row, column or this row. Beryllium is allotted this row. Magnesium is allotted this row. Sulfur is allotted this row. How this allocation is take place? That is our main point. That depends upon the structure of the atom. That depends upon the structure of the atom. For example, we can see the first group elements. What's the name of the first group elements? The name of the first group elements is alkali family, alkaline family. There is a special case, special reason why they are called the alkaline family. We can study it later in this class. Similarly, second group is known as alkaline earth family. First group alkyl family, second group alkyl family. Then why these elements are arranged in the first group? Let us have a look at the atomic structure of these four elements: hydrogen, lithium, sodium and potassium. Hydrogen atomic number 1, lithium 3, sodium 11 and potassium 19. Let us return the atomic structure of those elements. Hydrogen atomic number 1, electronic configuration K shell 1 electron. Lithium atomic number 3, electron configuration 2-1. Sodium atomic number 11, electron configuration 2-8-1. Potassium atomic number 19, electron configuration 2-8-8-1. When you look at the electronic configuration first elements, what you have noted? What is the peculiarity of the first elements? First two group elements, they have one electron in the outermost shell. The first two group elements, they have one electron in the outermost shell. For example, hydrogen, in the case of one electron, lithium 2-1, for sodium 2-8-1, potassium 2-8-8-1. Let us have a look at the second group elements. What are second group elements? Beryllium, magnesium, calcium, strontium. Beryllium, magnesium, calcium, strontium. For example, beryllium atomic number 4. This is first group. You can see the second group. Beryllium atomic number 4, electron configuration 2-2. Magnesium atomic number 12, electron configuration 2-8-2. Calcium atomic number 20, electron configuration 2-8-8-2. What is the peculiarity of the second group elements? What is the peculiarity of second group elements? They have two elements in the outermost. What is the name of the outermost electrons? In the lower classes you have studied about the number of electrons in the outermost shell is known as a special. Do you know? Do you remember? What is the name of the number of electrons in the outermost shell? The number of electrons in the outermost shell is known as valence electrons. The electrons in the outermost shell is known as valence electrons. So, how many electrons in first group elements? There are only one electrons. Second group elements, there are only two electrons. Then, you have the elements in the first group: hydrogen, lithium, sodium, potassium. We have seen the electronic configuration of these four elements similarly, and the radius is 100. What is the electronic configuration or the number group 1? What does this 1 represents? The group number 1 represents what? When you write the electronic configuration of these elements, what you have seen? There are only one electron in the outermost shell, or number of valence electron 1. Similarly, you have, this is the second group elements. Second group elements, what does this 2 represents? 2 represents the valence electrons of the second group elements. For example, we have seen the electronic configuration of beryllium, magnesium, calcium, strontium and calcium. This one, writing the electron configuration, we have seen that they have 2 electrons outermost shell, or they have 2 valence electrons. Similarly, in the case of 13 or 38, these A groups are known as representative elements. The third group, when you write the electronic configuration, you will, today itself, you will write the electronic configuration of these 2 or 3 elements. Then you can see that they have only 3 electrons in the outermost shell. They have the case of 14th group, they have 4 electrons in the outermost shell. These are 5th electrons, 6th electrons and 7th electrons, and these elements have 8 electrons in the outermost shell except helium. Helium, atomic number 2, it has only one shell, K electron. All the except helium, all electrons have 8 electrons in the outermost shell. So we are going to learn the fourth important thing. What is it? In the case of representative elements, the group number denotes the number of electrons in the outermost shell. Group number denotes number of electrons in the outermost shell or the valency electrons. Group number denotes the valency electrons. So, can you say, I said to that they came to one group because they have some common properties. The second group has they fall in second group, they have some common properties. Can you say why? The properties of an element depends upon the number of valence electrons. The properties of an element depends upon the number of valence electrons. If the number of valence electrons are the same, they have some common properties. Now I said 2 things. What are they? The properties of an element depends upon the valence electrons. If the valence electrons are same, they have common properties. Can you say again? Why they show common properties? Because why elements take part in chemical reactions? Elements take part in or took part in chemical reactions. Why? To attain stability. How they can attain stability? By attaining 8 electrons in the outermost shell. By attaining 8 electrons in the outermost shell. So today itself, in this periodic table is given in your textbook. You have a close look at the periodic table and find out the groups, the 18 groups and their names, and the number of elements in each group. Today you will find out the number of elements in each group. Then you point out each period. Then you also count the number of elements in each period. The next class, we can discuss the structure of the atom and the position in detail. So, in the other class I told you that you must make a simple tabletop periodic table. The next class I will request you that you must take the photo of this. You must make a period table and take the photo and send up in the WhatsApp in my WhatsApp number. Again repeat that. If you carefully study, it is very easy to remember if you know the elements and their positions, you can predict the properties and the study about chemistry becomes easy. Okay, thank you. We can see the next class.